Hello there, Water Watchers. This is Gary Burton. We're out at Prickly Pear today. It's a beautiful summer day, and we're going to be doing some water quality tests. The three tests that we're going to be doing: pH, temperature, and dissolved oxygen. That is the amount of oxygen that is trapped in the water for the bugs and the fish and the critters that live in the water to breathe. Our pH test is going to consist of putting a pH meter in the creek, which I have soaking as we speak, and it's going to measure the hydrogen activity in the water. Remember, water is made up of 2 hydrogen and 1 oxygen, H2O. So it's going to tell us whether or not the water is acidic or basic. Hopefully it's neither. The pH scale is not from 1 to 10 like we do a lot of different scales on a scale of 1 to 10. pH is 0 to 14, with 7 being right in the middle, and 7 is called neutral. That is perfect, pure, man-made, distilled water. Water in nature most likely is not going to be 7.0 neutral. If you think about all the different things that can be in a creek or a lake, the type of soil you have, the rocks, all of those things, pollution, they can affect the pH up or down. That's why it's a good test. It gives us an indication if something bad is happening to the creek. So let's take a look at the pH scale. So taking a look at our scale here, we see 0 to 14 with neutral or water being right at 7. Anything lower than 7 is an acid. Anything higher than 7 is called a base. So if you look down near the bottom of the scale, we have battery acid and lemon juice. Both are very strong acids. You're getting down near the bottom of the scale. Well, one of those I'm sure you've all tasted, lemon juice. The other, battery acid, hopefully you've never tasted. It just goes to show that pH is not a test to see if you can drink it. It is a test to see if it's an acid or a base. So a normal Montana stream would normally be slightly below 7, so slightly acidic. That is because our creeks are filled with rain and snowmelt. Rain and snowmelt typically has a pH slightly lower than 7. That's a mountain stream. Here at Prickly Pear today, we're down in the valley. Slowly but surely, as that water makes its way down out of the mountains to the lakes, Lake Helena is where Prickly Pear ends up. It's slowly accumulating minerals and things from the soil and the dirt and the type of rocks and leaves and grass and critters that live in the water. Normally our lakes around Helena are slightly above 7. So we're going to pull our probe out, our pH probe, and see what we get for a pH today. Remember, we want to be as close to 7 as we can. Alright, we have our probe soaking. Let's pull it out and see what our pH is. Looks like 7.6. So slightly above neutral. That would mean it is a base, and we are very close to 7. 7.6, so just 0.6 higher, which means we have a very, very good pH today. Alright, temperature is going to be our next water quality test that we can do. And it's a very simple, easy test. Thermometer, easy to get a hold of. And it actually can tell us quite a bit about the health of a stream. Here in Montana, we have snow in the mountains almost all year long. We got a nice summer day. All the snow is gone, so the creeks are getting quite low at this time. So if you can take the temperature of a creek in the summer, when it's been hot and dry, creeks are getting about as low as they're going to get. That is a good time to take the temperature, because we do not want the creek to ever get above about 67 degrees Fahrenheit. That is just too warm for the fish and the bugs that live in our creeks. If it does get above 67, those critters are going to have a hard time getting enough oxygen. Cold water can hold more oxygen. That's why we would like it to be nice and cold. Now, you will have different parts of a stream that will be different temperatures. A deep, shady pool is always going to stay a little cooler than a shallow riffle that's exposed to the sun like what's behind me here. So we've got the thermometer soaking, and we'll pull that out here in a couple minutes and we'll see what our temperature is. Again, we want it to be as cold as possible. Obviously, the time of year is going to have a great effect on the temperature of the water. But it does take water a lot longer than it does the air to heat up or cool down. That's why you can have water in the wintertime that's not frozen yet. Also, the deeper you go, the colder it gets. That's why fish in the lakes do not die when the lake gets above 70 degrees. It's very deep, and the deeper they go, the colder it gets. Same thing in a creek. A deep, shady pool is going to be where you can find the trout when the summertime is here and it's hot and dry. Hopefully we can always have a creek that is lower than 67 degrees Fahrenheit. Here's our thermometer soaking. Now remember, water freezes at 32 degrees Fahrenheit. It boils at 212 degrees Fahrenheit. The critical limit for a creek, 67 degrees Fahrenheit. We always want it to be lower than 67. So let's have a look. All right, zooming in on that, it looks like today we are right at about 56 degrees Fahrenheit. That is an excellent temperature for the middle of the summer when the creek is getting quite low. You can take a look around here. We were not in a really deep spot, but there's not a lot of flow to prickly pear today. Been a hot, dry summer, and we still have a very, very good temperature. All right, our final water quality test today is going to be dissolved oxygen. As I said before, cold water can hold more oxygen. Well, we had a very good temperature today for a summer day. I believe it was 56 degrees Fahrenheit. That means the water can hold more oxygen. If it gets above 67, that amount of oxygen that it can hold is going to go down. So it's kind of a reverse system. Water temperature goes up, dissolved oxygen goes down. If water temperature goes down, dissolved oxygen goes up. That's why we always want our creeks to be below 67 degrees Fahrenheit. We measure the oxygen in what's called parts per million. Now I'm going to give you a visualization. I want you to imagine a giant fish tank full of 1 million blue marbles. Those blue marbles are the oxygen. Now picture 6 white marbles mixed in. Those white marbles are the oxygen. So we have 1 million water and we have 6 oxygen. That would be called 6 parts per million. And that's what we need to get today in a creek like this for it to have a healthy amount of oxygen. 6 is okay. If it goes any lower, that's not good. If it goes higher than 6, that's even better. The higher it goes, the better it is. But there is a limit, just like you have a limit for pieces of pizza you can eat. Eventually, the water is full. Today, with the temperature of 56 degrees Fahrenheit, our limit is going to be right about 10. So we would like our results to be somewhere between 6, Higher is better. The closer to 10 it gets, the more oxygen there is for the fish and the bugs. So let's get our test kit. Alright, first thing we need to do, we need to get a water sample. Got my little flask here. Fill it up. Now we're going to add our dissolved oxygen reagent number 1. Give it a shake. Add number 2. Now what you're seeing here is a chemical reaction from the chemicals that I added. We'll shake it up. And it gets all cloudy and yellow with some floaties in it. That's called flock. That is supposed to happen. That's a chemical reaction that takes place when we add our chemicals to do our dissolved oxygen test. So we'll let that sit for a minute. Now remember, we need to get above 6 parts per million. Today with our temperature, the limit is right about 10. Hopefully we fall closer to that than we do closer to 6. All right, we're probably ready for dissolved oxygen reagent number 3. Give it another shake. Turns a darker orange, almost like apple juice. And now we are ready to test how much oxygen is in the water today, measured in parts per million. So we need our exact amount. We'll pour it in our test tube. And now transfer to our other little container so that we can add our drops. Now, for every drop of this sodium thiosulfate that I add, that represents 1 part per million of oxygen. When this turns clear, that is the total number of oxygen in the creek today. So let's keep count. 1, 2, 3, 4, 5. Looks like it's getting lighter. 6. All right, let's put something white behind it to see if there's any color. And it looks like there still is. Get the light better here. All right, let's keep going with our drops. We're at 6 right now, so we know there's a healthy amount of oxygen. Seven. Still yellow. 8. Ooh, getting very close. Just a hint of color. 9. I don't know if you can see that on the camera, but it is very, very clear. But there might be just a tiny, tiny hint of color. So we're going to add one more drop to see if it changes. If it does, the drop counts. If it does not, we'll stay at 9. I don't know if you could tell on the camera, but it did change ever so slightly, so that drop counts. 10 parts per million today. Very, very good oxygen content. In fact, we said that 10 was going to be about the limit today, so it's pretty much full. It's at as high of level as it can go. So excellent oxygen.